Google, you challenged us to make something better using science, and we want to make boating better by making it safer. I'm Alex Harmaty, and this is my younger brother, Adrian Harmaty. And yes, he's taller than me. A few years ago, my family and I learned about the death of 3 kids in a boating tragedy at a fireworks show in Oyster Bay that we, at the last minute, decided not to attend. The boat sank from the wake of another, with the kids stuck in the cabin. They simply weren't able to be found in time. What struck me was that the salvage team used bags of air to raise the boats. That was it. Just air. My father sarcastically said, "I think those bags would have been a lot more useful during the accident." His comment kept me up all night. It just made sense. Like an airbag for a car, but instead used for flotation. The question is, can we repurpose the same auto and salvage airbag technology to prevent boats from sinking? My brother and I were confident that it could be done. Our hypothesis was that with the proper sensors and bag design, an automatic system could prevent boats from sinking, increasing the chance of rescue to save lives. The idea had several challenges. The system needs several components such as automatic triggers for sinking scenarios, an air deployment system, and strong bags to handle the air pressure. After in-depth research, our methodology was to first break down the system into its individual components, its building, its testing, and redesigning until we had a working system. We coded 2 sensors that would act as triggers to set off the airbags. We used an accelerometer to trigger the valve when the boat exceeded a 90-degree angle, and a water sensor that would trigger the airbags when the boat took on too much water. We added an air deployment system made out of medical parts that operated on a different voltage. After a few failures and redesigns, we progressed our tests to a scaled simulation. The results confirmed that we've created an effective device. The conclusion, however, is that while the sensors proved to hold true for our model, the valves and piping would have to be enlarged in scale. While these logistical design challenges may seem reasonable, we can't be certain without a life-size simulation. Ultimately, we achieved what we set out to build, and that was a workable device that could eventually save lives.